I wanted to tell you about a little about our story and how we approached deploying a stateful workload in our Kubernetes cluster and how we approach protecting our precious data. So a couple of words about me. So I'm currently working as a chief technology officer in brand new cloud-native startup called Kubernetes. And we are working to automate some tasks related to data protection and enhance them. So I have a background as a Python developer, as an ops engineer, and I've been working with Kubernetes since version 1.2, and I'm a Kubernetes enthusiast. So, so as I said, I'm gonna bring you a story how we deployed our PostgreSQL database, and I want to talk how to backup and if we really need to backup PostgreSQL database deployed to Kubernetes cluster. And I'm gonna bring some theory about this, like what kind of backups are possible, how to choose a proper way to backup, and I want to mention a tool that we run into and we happen to use in our stack. Okay, so why we decided even to deploy a PostgreSQL database to Kubernetes? So our first decision when we started our startup was to go with Kubernetes. So we were pretty sure about this, and we had, this very straight stack with PostgreSQL database, couple of Python APIs around it, and services like Celery. So it's pretty classic. And we started thinking how to move it into Kubernetes cluster, and does it even make sense to deploy the stateful workloads or our stack inside? So we were on this decision whether to go with Cloud SQL or PostgreSQL, and what was the major what were the major reasons we decided to go with this database actually in our cluster? So we felt very courageous, and we dropped the idea of running Cloud SQL at some point, and we really wanted to use PostgreSQL because our team felt very confident about this, and some people even advised us to drop the idea. And we consider ourselves as a data protection startup, so why not to put a stateful workload in Kubernetes and protect it? And other major reason was we wanted to keep a very common way to deploy our services. And what really convinced us about running PostgreSQL database in Kubernetes cluster was the great tool done by Zalando called Patroni, and it's a couple of scripts that enhance using PostgreSQL database. So there are a couple of tools like replication configuration bundled inside. There is a backup tool inside this. There is a automatic failover mechanism. So in case we lost our master pod. And yeah, so what possibly look our day one operations day? So I don't really want to dig into technical aspects, how to what are the disruptions running in Kubernetes? So we all probably all know, like, your pods can die due to, for example, node updates and other external disruptions. So we trusted the Patroni stack. We trusted that it has this failover mechanism, and we like that it easiest to set up a streaming replica as a hot standby. So you can consider this like your first line backup, but is this really a backup? So I'm gonna ask this question later one more time. And other problem that you might want to consider in your day first operations is to choose a proper volumes, proper storage, proper classes in your cloud provider. And we run our infrastructure in GKE. And GKE, you have those two classes that can be dynamically attached to your containers, and it's standard class and the SSD class, so the magnetic and SSD. And at the very beginning, we choose the SSD, and we were aware of the trade-off we were making, because even though SSD class is the best performant available in Google Cloud, well, you're still making this trade-off of performance. So comparing to a bare metal setup, you will lose something like about 3 times on I/O operations. So at some point, you might be tempted to look into a local storage of a node, but I wouldn't recommend it at the first place, because you're gonna have some scheduling issues. And local storage is the storage tightly coupled to your node. So losing a node, even for a while, is hard loss of your data. So if you really need this cutting edge performance, you would probably look into something called cloud native storage, and there are a couple of cloud native storage providers. So the idea behind this is to introduce a separate layer between what Kubernetes, how Kubernetes understands volume, and what's actually underneath. So, for example, we're currently looking into Portworx as a storage provider, and this solution kind of utilizes block storage attached to your node, and it makes local storage less likely to fail. Like if you weren't using this this approach. So that's definitely something worth looking into if you look for performance. These tools usually have their own mechanisms of backing up data, and have introduced mechanisms to, for example, resize your volumes and generally make it more consistent. So sorry if I forgot someone here. There are a couple of available providers, a couple of more. So okay, so I got this cool deployment with FileOver, so I'm pretty sure that my database setup is going to work. And the question is, do I need to backup? So I have this replica, and I got this, failover mechanism. So if I lose master pod, it will dynamically switch to replica, and I got my services up online again. And the answer obviously is yes. And why would you even backup replicated workloads? So replica doesn't really protect against software and configuration bugs. So if you write a wrong code that, for example, deleted some data, or due to the evolving due to a rapid development, you forgot some configuration, or you lost this configuration, so you lost this replica data, and that's gonna be a problem. So another thing is a human error. So if you don't really manage your resources from some single source of truth like Git, you are more vulnerable to human error. So if your admins are doing some manual work there, they're also, so those resources are also vulnerable to be lost. And usually when you deploy your replica, it usually lives near the original one. So if, for example, a zone is going down, so both pods are going down. And what if you lost an access to your resource? So I don't know if you've heard the story about a young startup that was running in one of the cloud providers, and some automated bot dropped their access and stopped their workloads on VMs. And it pretty much killed their business, because they couldn't access their subscriptions for 2 days. And if they had backups in different subscriptions, they could have just restored to those to different clouds and get some just a little delay in their business. So yeah, that's it. So sometimes you might want to restore to an older revision, like client asks you to do explicitly to do so. So client might delete its data and figure out still needs it, so and pays lots of money for this. So yeah, worth considering this. So, and other reason is for debugging purposes. So sometimes you want to move an older revision to a dedicated cluster, isolated, and do some debugging or testing on this. And worth mentioning here that this usually requires some anonymization of data. It's not good to work on a play data from production. And it always feels better to have an independent way to protect the data. Better sleeping, right? And what to really back up in Kubernetes? What kind of resources make sense to be backed up? So if you're running a stateless workloads, Git will be your source of truth, so you won't need any sort of backup for those. And yeah, so that only works if Git is your only source of truth. But what if you do some manual actions? You would probably be considering like backing up etcd. Unfortunately, it's not possible to do in GKE. And what, in my opinion, makes sense to consider is an API server resources and persistent data, of course. So what are the backup types we can do to our persistent data? So there are two major backup types. It's logical backup and physical backup. And the first one is about to backup data on an application level. So probably no pgdump. And these kind of backups usually utilize some some special format and store the data in files. And those tools usually provide the best consistency, but on the other hand, they are very slow. So what comes next is a physical backup. Physical backup is about to backup files or even bytes. And this usually is a faster approach, but introduces consistency problems and will be a huge problem in the distributed systems, distributed applications. So because you are going to have a problem to pick up the consistent state in the right moments, right? Because you have multiple volumes there. And this approach usually requires to stop the application, flush file system cache, and then perform a backup, what's called a cold backup. And opposite to this is a hot backup, when you backup your data, your application online while it's accepting requests and processing the data. And you probably know that backups can be either full or incremental. So full is pretty straightforward, where you dump the entire application, and incremental means you save only the changes, the recent changes. So how to choose the method, the right method for me? So there are two parameters that help specifying this, and this is a recovery point objective and recovery time objective. So these are parameters that usually come from business analysis. And well, it happens in a bigger company. So in a smaller startup, I would have define them by myself, and reasonable values, and that's it. So recovery point objective is the maximum period in which we might lose the data, and time objective is means how much time do we have to restore our systems back online. And if we somehow define those parameters, if we get from a business analysis, so we figure them by ourselves, so we can go and pick the right backup method. And what comes next is to think of a disaster recovery scenario. So disaster recovery scenario is pretty much what we have to do when something happens, something bad happens. And so defining a good DR scenario is asking good questions. So what could happen? And at the beginning, I would have advised to go very simple, to focus on data and workloads itself, like do not consider advanced security scenarios or stuff like this. So, and what's most important about this to test this disaster recovery scenario. So if you back up your data, try to restore it, because there are many people that just back up and forget to test recovery paths, and that's gonna hurt. And it's always good to check against these two parameters I've told you before, just to just to track it if those conditions are met. And so what? Sorry. What if we have like a very changing environment. Like we get a lot of data and it grows rapidly. So like even an hourly basis backups won't be enough. So here comes something called continuous data protection, and it's all about to back up the data whenever any change is made. So like updates, inserts, deletes are pushed to somewhere else. And this guarantees us that we don't lose anything. And this approach really helps to achieve something near zero RPOs. And in the stack we chose, there is a cool tool bundled called Wally, and it's a continuous protection tool that requires some configuration and works out of the box. So, other thing I think worth mentioning is isolation. So it's good to keep your backups in a separate subscriptions provider. So if we have our infrastructure running in GKE, best idea would be to store our backups, for example, in AWS S3, right? So even something happens to Google, so it's nearly impossible. But if our subscription gets compromised or something, we still have a separate subscription, and we still have data in a separate subscription. So it's always good to have a different scope of permissions for those subscriptions, and the good practice would be to dedicate a team to do this. So it's common in bigger companies when they dedicate a group of people to just manage backups, keep them safe, and they manage to manage the entire process of recovery, backups and recovery. And developer teams might not even know about them. And in this approach, it's always important to remember to encrypt this data, because there might be people that are not allowed to see this data, right? And another important and good practice is to automate everything. And at some point, we looked for an end-to-end solution, and we happened to use a tool called Valera. So yesterday was a great talk about this, done by Emil, and there's a very detailed presentation about this, so I recommend to watch it as well. So I'm going to mention a couple of features that were important to us, and it backups persistent data, and it also backups manifest in your Kubernetes cluster. So you pretty much get everything out of the box. It works two ways. You can, well, Valera is aware of cloud provider that is running in, and could utilize cloud provider API to schedule volume snapshots. And there is an alternative way, cloud agnostic, where Valera uses a generic backup tool called Restic. It's a file system level tool. And Valera supports a couple of major cloud providers like GKE, AWS, Azure, IBM, I believe, and a couple of others. Very cool thing about this is it's declarative. It uses CR, so action of scheduling backup and restores are expressed in CRDs. So some automatic script can consume them, and humans can use them also. It works for DR, so it's a limited tool. You cannot like move into a older revision with this. You have to explicitly delete your resources because it looks across your resources and it brings up missing ones. And okay, so our current setup is to use Wally bundled in Patroni stack. We use the Lambda operator. That's very good, very good thing, good quality, and I think can be considered production ready. And in case of a disaster, we try to recreate a brand new cluster, and the Lambda operator gives a very friendly way to do this. You can declaratively say that, please give me a copy of this cluster just before this timestamp. So, and it fetches this data from S3. And we still use Valera backups as a redundant way of protecting our stateful workload. The main reason is it protects your manifests, and it gives us another way to protect persistent data. So we build the entire scripting around this and try to automate as much as possible. And if we are about to deploy a brand new stateful workload, would be, in terms of data protection, would be to use as much generic approach as possible. And Valera with volume snapshots is a good starting point for this. In the second place, I would look for a continuous backup tooling, just because it requires much more effort and much more configuration, and sometimes custom scripting around this. And in the third place, I would look for logical backups like pgdump, and pgdumpall, mongodump, and stuff like this. And the reason for this is only if the first two are not sufficient for our workload. There is no other way, like performing a logical backup, because the dedicated tool will be probably aware of the deployment itself, so it will probably take care of the consistency problems, so the distributed nature of this, and that's it. So if you don't have an automated tooling around this, I would have started with Kubernetes cron job. That is invoking this dedicated tool, and that would be a great start. So try to pick two solutions if possible. So it's always good to have a redundant way to protect your data. So in case the first one fails, or okay, so what are possible improvements to our backend services is to build a disaster recovery cluster, which will be a hot standby. We are looking into it. just mentioning it's a better way to do this, because you're gonna have a best reliability and time of switching to the solution, and automate more. So more scripts, self-managing, self-healing, and that's it. So we are considering to moving to regional cluster. So we are in a single region right now in GKE. And last most promising thing is to use open policy agent, where we try to enforce some policies inside our cluster. For example, I would enforce our deployment service to do the backups. I would enforce our deployment service to change any resources, like perform deployments. So Valera could only touch backup other resources and backup resources and stuff like this. So it's pretty promising approach in terms of security and in terms of reliability, in terms of reducing possible disruptions, possible human errors, and that's it. So to sum up, there are multiple methods to guarantee business continuity. A mix of them gives the best results, and I've mentioned a couple of them here. So standby replicas gives us best RPOs, and RTOs is just switching, so it can be a couple of seconds. Backups are always important because they get us a better reliability. And most important, automation. So to make the processes repeatable, to eliminate the human error and keep the resilience best. And so Infranetis is a brand new cloud-native startup where we manage backups and we provide a migration solution. So all the problems I mentioned just before we encapsulated and in our tool and build a platform for this. So if you happen to have similar problems, so if you thinking of protecting your data, or if you're thinking of running stateful workloads in Kubernetes, so it might be a good thing for you. And that's it.
Do you do recovery test, emergency recovery test, like
not yet.
Disaster?
Not yet. Okay. So we're looking into automated tests for this, but it's on our roadmap. So this is something we also want to support in our tool.
So you mentioned using local storage as an option when you need more performance. Did you explore like replication, and so why can't you use the local storage and then if the node dies, just switch to the other node?
Well, you can, but local storage is going to give you a little trouble at the beginning. So because it's a storage physically attached to the node, yeah. So if you're okay with this, if you're aware of that, so it's okay. So you probably know how to schedule your pods to make them running on the right node, because well, the Kubernetes itself won't be able to schedule the pod on the right node. If you use local storage, you need a custom scheduler for this, and those storage native providers are actually the real life example where they provide you a custom schedulers to at least Portworx to handle this.